Hey guys, we're here with Chris, the co-founder and CEO of Authereum. Can you just confirm that you can hear him, and we will be able to get started?
Hey guys. Great. Hey, Adam. Great. So my name is Chris Winfrey. I'm really excited to be here. I'm a co-founder of Authereum. And today we're going to be talking about contract-based accounts and how they apply to DeFi. And then we're going to look at creating our own DeFi protocol without writing any smart contract code, just using contract-based accounts. If you have any questions, you can drop them in the chat. I won't be able to see the chat while I'm doing the presentation, but I'll try to answer everything at the end. So I'm going to turn off my video here and share my screen. Great. So really quick, I'm currently working on Authereum. I got my start in the Ethereum space about 3 years ago. I started the Boston Ethereum developer meetup and then co-founded Level K. And we built projects for a lot of cool teams. We audited a lot of cool projects like Augur and DYDX and Decentraland, and just got to work with a lot of cool people across the space, see a lot of really great smart contracts. And I moved out to LA about a year and a half ago when I met my co-founders, Shane and Miguel. And all of us were frustrated with the user experience with Ethereum, and we saw like contract-based accounts emerging, and saw this as an opportunity to try to tackle some of these usability problems and onboarding problems with contract-based accounts. And so today we're going to talk about some of the problems that we face with regular Ethereum accounts. We call them EOAs, or externally owned accounts. We're going to jump into what is a contract-based account and some of the differences and the cool things that we can do with contract-based accounts. And then we're going to dive into the main feature that I want to talk about today, which is batch transactions and how they work, and then specifically how Authereum batch transactions work. And then we can look at how we can apply batch transactions to DeFi and jump in some code and build our own DeFi protocol that will allow users to lend ETH and earn interest on their ETH. And we can build one that actually beats out the rates on all major decentralized platforms today, including Compound. We're going to use Compound, but get a better rate, DYDX and Aave. So today, most of us use what's called an externally owned account. And so an externally owned account is just a public key, a public address and a private key. And externally owned accounts are very binary in that either you have full control over the account or you don't have any control at all. And whoever has the private key can either access all of the funds or none of the funds. And so this works for some use cases, especially if we're just like holding on to crypto. We want to, throw it on a ledger and throw that ledger in a drawer, and we're not really using it. But it's not really great when we're using our account all the time, and we're hopping around different applications, and possibly risking exposing that key, or might want to have more granular controls over how much can be spent from the account and that kind of thing. And so more recently, we've started to see contract-based accounts emerge. And so contract-based accounts enable a lot of cool features and then also introduce a lot more complexity. So, there's trade-offs, but I think as, the space matures and as contract-based accounts mature, we're definitely going to see a movement from externally owned accounts to contract-based accounts because of the usability benefits and their ability to kind of abstract away all of these concepts that we've gotten really used to, like gas and seed phrases and that kind of thing, but that the rest of the world is just clueless about and won't be able to onboard to Ethereum if those are still barriers. And so with contract-based accounts, we're going to talk about batch transactions later, but that is one of the coolest features about contract-based accounts. We can do meta transactions, Web 2.0 security, and recoverability. And so all of these things are things that aren't really possible with regular accounts. You have to have a contract-based account to do these things. But they open up the doors for a lot of cool user-facing features because we're using these different design patterns. And so the first one I'm going to talk about is meta transactions, because meta transactions are so core to contract-based accounts. So with a contract-based account, all of your funds are held in a smart contract, and you have one or more keys that can access this smart contract with your funds in it. But none of those keys actually have any funds. So they can't make transactions on the Ethereum network because they don't have the ETH to pay for the gas. So that's why all transactions with a contract-based account need to go through a meta transaction because we need someone to pay that transaction fee and actually broadcast the transaction. So a meta transaction is when a user takes their key that doesn't have funds in it, is just used for signing data. They sign the transaction data. Then instead of broadcasting it to the Ethereum network like a regular transaction, they're going to send it over to what's called a relayer. And the relayer is just a process that's run in a server, and all of it's doing is listening and waiting for the signed transaction data. And once it gets the signed transaction data, it calls the user's account contract with the signature and makes the actual Ethereum transaction and pays for the gas. And depending on how that relay is set up, they might be, it might be a dApp that's sponsoring the transactions on behalf of the user, or the user might be paying for their transactions, in which case the relayer would be taking a refund from the user's account. But what's cool about meta transactions is that because the user isn't actually paying for the transaction directly, they're just refunding the relayer. The relayer can accept any currency they want as a refund. So now the user, from the user's perspective, they can pay for transactions in other currencies like DAI, other stable coins, or maybe an application-specific token, so that they don't have to deal with multiple currencies to use an application when they need to pay for the transaction. But in other cases, we can also let dApps sponsor their users' transactions, and that way they can just transact and not have to worry about getting funds to transact first. And so basically, a meta transaction is a transaction that one account, our relayer, makes on behalf of another account, which is our user or our contract-based account. And so another cool thing that we can do with our relayer is we can set up Web 2 style security. And so by Web 2 style security, I mean things that you'd commonly see on an exchange like Coinbase or with your bank, where they are looking for suspicious activity and using that to cut it short and then notify you of suspicious activity, and just making sure that they protect you from any attackers in that way. And so what we can do with meta transactions is that we can set up a relayer that also protects us using Web 2 security. And so because we have many keys that access this account, and our contract-based account is completely programmable, what we can do is set up some keys that are more exposed and are kind of the ones that we're using most commonly. We can set those up to be only used by a specific relayer. And then we can set that relayer up to only broadcast the transaction if it trusts the context that those keys are transacting from. So that way the relayer can block a transaction if it thinks it's from an attacker. And then we can have other keys that have full control over the account and aren't provisioned to any specific relayer, so that if our relayer goes rogue or it goes down, we're not dependent on that relayer. It's not a point of censorship, and it's not a central point of failure. We can always circumvent it with our keys that are more protected. And that way we always have full full custody of our own accounts. And so that actually provides us a much more secure experience, because now we can tie in, things like browser fingerprints and searching for, which IP address, and if a dApp becomes malicious, then it can be blacklisted by the relayer, and we can do all this stuff that just wouldn't be possible with a regular account that's just completely binary, where, with a regular account, if that key gets compromised, your entire account is compromised. And so one of the other cool things we can do is recoverability. And so again, because our contract's completely programmable, we can recover, we can add keys to this account. Maybe it's our MetaMask, maybe it's a ledger that we throw in a drawer, or, a bank vault somewhere. But we always have a backup to fall back on in case, with Authereum, you can basically log in with your username and password. Say you forget your password, you'll have something to fall back on just in case. And this is something that again, with a regular account, it's totally binary. So you either have control or you don't. There's no, I lost control of this key, I'll use my backup key to regain control of my account. Or maybe I'll set up a social recovery process and allow my friends to start a recovery process on my account. And so the main thing I want to talk about today is batch transactions. And so when we started Authereum, it was a little less than a year ago. We knew that we were going to be building batch transactions, but it wasn't really what we were excited about. We were really excited about recovery. We were really excited about Web2 security. And we were really excited about the portability that it brought to these accounts. So by portability, I mean, you can just log in a desktop, you can log in on this, same wallet on your mobile phone in Safari, and then we can even let dApps create mobile apps, and they can just log in right in the mobile app and just have the same account everywhere. But batch transactions, like we saw it as an opportunity to, save some gas, maybe make some user experiences better, but we didn't really see it as the way we see it now, which is one of the core features that unlocks all of this functionality with contract-based accounts. And so to take a step back here, let's look at how just a regular externally owned account would transact with a DeFi protocol. So in this example, say we want to lend our DAI out on Compound. And one of the big limitations of an externally owned account is that in a single transaction, an externally owned account can only transact with a single contract. And so that means that if we're lending out on Compound, we first must approve our DAI to be lent out on Compound. And then we wait for a block confirmation. Once our block confirmation goes through, then we make a second transaction to lend on Compound, and then we've actually lent. And so this is a really, it adds a lot of friction to the user experience, and dApps know this. And so we introduced this really, really bad practice in Ethereum because we've hit this usability hurdle where we don't want the user approving and having to make multiple transactions every time. So what we've done instead is just ask the user to approve an unlimited amount of tokens. And this is not good, especially when we're dealing with stuff like upgradability, even if there's governance around it, because if the contract that you approved to got hacked and was able to pull those tokens, now it's not just the tokens in that vulnerable smart contract that are vulnerable, but it's also all the tokens that you've approved to that contract, which is when you're approving an unlimited amount is just everything in your wallet. So all the DAI in your wallet. So this is a really bad practice. It introduces trust into the system, because now you need to trust this third-party smart contract basically forever, unless you go back and unwind your approvals. And so what we want to do with contract-based accounts is stop this practice and stop having dApps do unlimited approvals. And so what we can do with a contract-based account and what this interaction looks like is we actually batch these two transactions together. So we now have our relayer. So we're no longer transacting directly with our account, but through a relayer. And our relayer calls our account with our signed transaction data, which contains both of our transactions. And then one of them approves, and then one of them lends. And this is really nice because, one, the user doesn't have to wait through multiple confirmations. But what is really nice is that now we can just completely abstract away the approval concept from the user. Because again, the user doesn't understand, especially new users, doesn't understand, what it means to approve to a contract and why they have to do that and why it's a separate transaction. And if we do it in a batch transaction, they don't really have to approve. They can just do the thing that they came to the dApp to do, which is lend their DAI out and earn interest. And then the other nice thing is that because we're batching it and it's no longer inhibiting the user experience, we no longer have to approve an unlimited amount of DAI or whatever token we're using to the contract. We'll just approve the amount that's needed, and that way the user doesn't have to have this like extra security vulnerability just because the dApp wants to provide a better user experience. And so before we dive into how we can use batch transactions with DeFi and composing DeFi protocols, I wanted to talk about one more feature of specifically Authereum's batch transactions. This might not be how other contract-based accounts implement their transactions, but we think it's really important, especially when it comes to DeFi. And so with our batch transaction, when we make it, each transaction will either succeed or fail. So say our first transaction succeeds and our second transaction succeeds, but our third one fails. And so what we do is it's what we call an atomic revert. So it either the entire transaction reverts or the entire transaction succeeds. And so if that third one fails, it actually unwinds both the second one and the first one. So the user's never left in this weird state where some of their transaction went through, but then it failed midway, and then they're stuck in this weird state. And if you're using an externally owned account and making each of these transactions individually, and you get stuck on the third one, now you have to go back and unwind the second and first one yourself if you can do that. And so how can we use contract-based accounts with DeFi? So I actually want to jump in some code here. But at a high level, we're going to make a DeFi lending protocol for ETH. And so the ETH rates for lending across DeFi are super low. If you look at LoanScan, they track all the rates across DeFi, and you'll see on Compound, it's basically zero. On DYDX and Aave, they're just a little bit higher. So this protocol is focused on getting a higher return on lending ETH. And so what we're going to do is we're going to create a vault with Maker. We're going to deposit ETH into that vault, which is going to then allow us to mint new DAI, and we're going to withdraw that DAI, and then we're going to lend that DAI out on Compound to start earning interest. And we're going to do all of that in one transaction in a way that is abstracted away from the user. And so let me really quick, I think I need to share a different screen here. Can you guys see the screen? So this is what our lending app looks like. So we've abstracted away the underlying protocols and just made something that's really simple for the user to understand, that they're just lending their ETH. And we're going to jump in some code here. So you can see that we set up some constants. And so this is just defining the different contract addresses that we're working with. And then we're using ethers. I prefer ethers over Web3, but this would also work with Web3. And so we're also setting up the different interfaces that we're interacting with. So on the DAI contract, we're going to be using approve. On the Maker contracts, we're going to be looking for this event, new CDP. We're going to be looking for or using open, lock, ETH, and draw, and wipe all and free ETH. Maker has you pass in a bunch of contracts. I won't get too deep into what each of these are. And then they also have a proxy interface that helps make some of these interactions a little easier. And then lastly, on the CDI contract, this is Compound's contract. They set up as an ERC20 called CDI. And we can interact directly with the CDI contract to lend on Compound. And so we're going to be using Mint and Redeem underlying. And so on our, and also if you want to check out this code yourself or follow along with the actual code, you can check it out on the Authereum GitHub. The repo is called lend-demo. And so this is our lending batch transaction. You can see that we're taking all the constants that we defined above, and this is basically all the code that we need. And this is where the magic happens. This is our batch transaction that we're sending out. So that's all the code that we need. We don't need to write a smart contract. We don't need to deal with any of that stuff to get our application out. We could just use batch transactions. And so first we're going to open our vault. So this is dealing with the maker interface. We're going to call our open, lock, ETH, and draw function. And then we're going to do it with the amount of DAI that we're lending. And we're lending 20 DAI. And we're going to be locking up 0.23 ETH. So we can't actually lend the entire value of our vault because we need to maintain a good collateralization ratio. So we're just going to, our vault's going to be worth about $50. We're going to be lending 20. You could probably be a little more aggressive about that, but that's the way it's set up today. And so Maker has you go through a proxy interface. I won't get too deep into that, but basically our open vault transaction is going to look something like this, where it's going to go to the Maker proxy. We have our transaction data. We're going to send, this is the amount of ETH, our 0.23 ETH that we're going to lock in our vault, and then our gas limit. Our second transaction is going to be our approval. So again, we're only approving the exact amount that we need. So this is just our 20 DAI that we're going to be lending, and that's, we're not approving an unlimited amount. And once this is used, there will be no lingering approval to the CDI contract. And so we're approving it to the CDI contract because it's a CDI contract that needs to withdraw it from our contract-based account. And so this is our approval transaction. And it's going to the DAI contract because it's the DAI token that's being approved. And then lastly, our last transaction is going to lend out our new DAI that we minted out on Compound so that we can get a better interest rate than any of the other protocols while still maintaining full exposure to the ETH that we hold. And so we're just going to call a mint on our CDI contract, and then that's going to get our call data. And then we're going to call the CDI contract with our mint call data. We don't need to include any ETH in this one, and we just have a hard-coded gas limit. And then this is the Authereum provider. So this isn't, we are working on pushing this as a part of the Web3 provider standard as we start to see like more contract-based accounts emerge and more contract-based accounts that can support batch transactions. It will make sense to standardize this. But right now, we just expose it on our own provider ourselves because it's not a part of the Web3 provider standard yet. But you can see these are just transactions that you would each individually use with like web3.eth.send transaction or the equivalent with ethers. But instead, we just pass it in as an array, and then this will all get executed as a single transaction. So we can try a live demo here and see if it works. And you can see my Authereum account has 0.583 ETH in it. We don't have any CDI. And so we've sent our transaction out to the network, and now we are earning interest on our ETH. And so the rate that we're earning is going to be, about half of what Compound's DAI rate is, which is the half of the DAI rate. If we look at loan scan here, we can see that that's about 2%. Whereas if we were to be earning interest on our ETH elsewhere, the rates would be very, very low. So we can actually get a much higher rate on our ETH than a lot of these decentralized protocols. And so this is Etherscan for our contract address. You can see here 3C6, and this is 3C6. This is the transaction we just sent. And so if we dive into what happened here, we can actually see that we sent 0.23 ETH into the Maker system. Maker wrapped that ETH into wrapped ETH. It then got deposited into a vault. And then we were able to create 20 new DAI from that vault and withdraw that DAI. And then we send it over to Compound, and then we get CDAI, which means we're now earning interest on our DAI. And that all happened in a single transaction that reverts atomically and abstracts away the underlying protocols. And if you can see, all the interactions have fired off over 30 events in our single transaction. And then when we're ready to stop earning interest, and then we can see that I now have CDAI in my contract and my ETH has been withdrawn. And now when we're ready to stop earning interest and we want our ETH back, we can reclaim it. And that will be fired off to the Ethereum network as a meta transaction. So what's happening here is we actually signed the transaction data, the entire batch transaction within the browser. That signature along with the transaction data gets passed to the relayer. And then it is the relayer that actually makes the transaction. So if you look here, this is the transaction to unwind the lend, and the from account is actually the Authereum relayer, and it's to the contract-based account. And you can see that we paid our DAI back to our vault. Well, first we redeemed our CDAI for DAI with Compound. We paid our CDAI back, or we paid our DAI back to our Maker vault, and then we were able to withdraw that ETH from the vault. And now I have 0 CDAI in the account, and my ETH is back, and I've successfully lent my ETH out for the highest interest rate out there, and then redeemed it with a batch transaction. There was no two-step approvals. We didn't have to worry about stepping through processes across multiple protocols. We were able to compose these different protocols into something that is to the user is completely new.
Hey, Chris, not to interrupt, but we are running out of time. We have 3 more minutes. So okay. If you can wrap up and maybe give these people some place they can go if they want to learn more, that'd be great. Maybe a GitHub or your Twitter would be great.
Perfect. I'm actually done now. And yeah, so let me just share my last slide. So thanks a lot. And if you want to check out the code for that application so that you can get started making your own DeFi protocols with batch transactions without writing any smart contract code, check it out on our GitHub, Authereum/lent demo. You can check us out at authereum.com. Find my GitHub at cwinfrey and follow me on Twitter at winfreychris. And then if we have any more time here, I will try to answer some questions.
Maybe one question?
Yep. So given that it's not possible to sign data using a contract-based account, how can we detail with blockchain TX that require user signature between? So there's a EIP for this, and it's called 1271. So right now Ethereum supports EIP 1271 signatures. And so this is going to work really well for any signatures that aren't used as a commitment, because one of the hard things about 1271 is that the user or the contract-based account can invalidate the signature at any time. So at Authereum, we're actually thinking about a new EIP that can be used for signatures that's similar to 1271, but can be used for signatures that are needed for like layer 2 solutions and stuff, where you need to make a signature that acts as a commitment. Cool. Thanks a lot for having me, and it was great to be here.
Thanks, Chris. This was great. We're going to switch into the next session now.